Hello, I am Cem Kaya.
Hello, I am Emre Caneşki. Before we make the demonstration, we wanted to explain our project a little bit. In this project, we are trying to simulate a door security system, uh, which when someone comes nearby, it take a picture of them and then analyze the picture to see if it's someone from our database. And if he is, it asks for a password, and based on the password, it will open the door or not. But here, since we cannot find a suitable way to open a locked door, something like that, we just light a LED. You can go to the next page. Next, oh yes. In here, there's a flow chart for our program. It starts for measuring the distance, and if something came 25 centimeter close or not, it takes a picture, and after it takes a picture, it sends it to the server to analyze it. If it is not someone we recognize, it will just print that and go back to the measurements. If it is someone we recognize, it will ask for a sound to make, and if when the user make a sound, it will start recording it. After that, if the password is correct too, it will we will send the password to the server after recording, and it's detected language that is spoken, and based on the detected language there is different password, and it's that look for the true password or not if the spoken language. After that, it's less likely necessary less.
Okay, so here are the sensors that we used. We used an ultrasonic distance measurement sensor. This sensor is comparatively lower power to the camera. We use this sensor to detect if someone is in front of the door or not. Then we are using a camera to take the picture. Then we are using a digital sound detection sensor. This is like a microphone, but the output is binary, so it detects if there is a sound or not. This is comparatively lower power to a microphone. And lastly, we use a real microphone to detect, not to detect, but record someone's voice. And the models that we use. So, like I said, there is no machine learning in the distance measurement part, but once we take the photo of the user, we send this to our server. In our server, we are using a VGG face model. We try to fine tune this model, and like the training process is very similar to contrastive learning. For a given person, we have multiple pictures of them, and then we try to the VGG face does a representation learning on this model. So it creates an embedding. So for the same person, the embedding should be similar, and for different person, the embeddings should be different. Also, we can augment the pictures. So let's say you have my face in database, and we augment this picture in different ways, and the extracted embedding should be similar, but when I embed someone else's face, the extracted embedding should be different, so it should be far away, and this is the training. So once the VGG face model creates the embedding, we use a KNN machine learning technique to detect if that person is in our database. We experimented with different numbers of n, but we found that using n equals 1 and multiple pictures in the database worked better. We also have a threshold to determine a distance threshold to determine a person is in our database or not. Once the system determines a person is in our database, it sends the person's name to the edge device, and edge device starts to listen. But before it starts to voice recording, the user has to make a sound. So we use our noise detection sensor there. Once a noise has been detected, we prompt the user to say the password, and we start recording. The edge device records the sound and sends this to the server. And we use OpenAI's Whisper model to transcribe the spoken word to text. And OpenAI's Whisper model is a humongous natural language processing model. It has 1.6 billion parameters. Like, it requires a very beefy computer to run, like at least 10 or in this case 12 gigabytes of VRAM to run it on a GPU, or similar amounts of, I mean, a bit more RAM to run it on the CPU. But using this model, we can detect spoken words in 200 languages. But it is a bit too good in detecting languages. So since we are not native speakers, we don't enunciate words correctly, and thus we have to accommodate different variations of the password to get a better result. For example, when we say password, it can detect we are Turkish native speakers and try to process it as Turkish, and it can read password as passport, which are phonetically very similar. So while post-processing the output of our model, we have to take this in consideration. But it can detect Turkish, English, and multitudes of other languages pretty good. It can detect over 200 languages, like using 1.6 billion parameters. It has been trained by OpenAI for a couple of $1 million. So this is all the machine learning we do. And this is our final edge device. There's a Raspberry Pi, there's a camera, there is a ultrasonic distance measurement sensor, there is a microphone.
Sensor, one for ultrasonic sensor for detection. It sends a laser and check how long it takes to come back. As you can see, the more I come, the distance is proportional. The other is a car sensor, which detects sounds. It just detects if there's a sound exists or not. And we use camera to take a photo and send it. And now
Also, we use the microphone to record the sound.
yeah, also we use
It is on his headphones.
yes. And in the final, according to detected person, we run a LED, a light LED. Now we can, I think, show a demonstration of it. No, firstly, in order to detect if a person is approaching the door or not, it will look if the distance is 20 cm or lower. First, for demonstration purposes, first we have to come near the door. So for this, we look if the distance is smaller, 20 cm or that. So I'm going to put my hand on it for right now. So it will take a picture. Password. As you can see, it says welcome Emre. Now we will take the password, please wait, and then it will look for a sound detection. Unfortunately, I was speaking at the time, so it did not look that part. It just detects sound immediately. As you can see, the last assigned for me was this one, and it is running right now.
And the other one is not lit on because he doesn't have permission to enter that door.
Yes. It's working to different person. Could you put a distance of 20 cm? As you can see, it say welcome owner, and then it wants to make a sound recording.
Password, 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 password.
Now we can see Honor LEDs. For Honor, we run 2 LEDs at the same time. It has permission for 2.
Thus, he can enter both doors if we had actuators.
Yes, and yeah, right now.
This is the whole system. We utilize an edge device, a server for computation, an ultrasonic distance sensor, a sound card, and a microphone. In the server, in our database, we only store the people's faces, and when the server is rebooted, it recomputes the embeddings. Thus, it is very easy to modify and add new papers to our server. And the priorities are only kept in edge devices. Thus, we try to make it a bit more secure. If the server is breached, the data which would leak were the workers' faces, and if an edge device is breached, the only leaked data would be the names of the people who are allowed to enter that door. But I mean, just for specifically that edge device, not the priorities for all the network, all the edge devices. Thus, we try to separate information such that it would be a bit more secure if we stored everything on edge or everything on server.